Welcome to the video lecture on calculus. Let us discuss a very fresh topic today, that is mean value theorems. Mean value theorems. Now, what are mean value theorems? Let us understand this particular aspects. There are three types of mean value theorem which is in our syllabus we'll be discussing. Number one is Rolle's theorem. Now, what does Rolle's theorem states? First we'll talk about that, and then I'll tell you what is the physical interpretation of that particular thing, right? So Rolle's theorem said was, you're talking about the statement first. Statement. What was the statement of Rolle's theorem? He said that if a function fx is continuous in the closed interval a comma b. Second, if a function fx is continuous in closed interval a comma b, its derivative, you can say f dash x, exist for every value of x in the open interval a comma b, and the third condition he says is f of a should be equal to f of b. Then he says that then there exist at least one c such that f dash of c is equals to 0, such that f dash of c is equals to 0, right? Now, what do I mean by this particular thing is, let us understand. You also have to understand that this c belongs to a comma b. Not belongs to, we should say that c is between a and b, right? Now, what I'm trying to say is, let us understand. What is Rolle said? Rolle said, let's say there is a graph, there is a function of not this nature, let's say. There is a function of this nature. It's not a standard function, but any function, let's say. This is a, this is b, right? So let us say this is the graph. Let us say here we have f of a, here we have f of b, and they are both equal. They are both equal. You can see the graph on the y-axis basically, right? This is, let's say, x, and this is the function fx, right? So what we are trying to say is, according to Rolle theorem, what is saying that if fx is a continuous function in this interval, right, and f dash x is differentiable. That means there is no discontinuity basically we is talking about. Then and f of a is equal to f of b. Then what is saying that there exists at least one c. There have to be at least one c where f dash c is 0. Now what do I mean by f dash c should be 0? A derivative 0 means an f dash c 0 means, see, f dash c is nothing but slope of the curve, isn't it? Now slope 0 means that the curve is twisting, the curve is changing its sides. So that means f dash s should be 0. That means there the curve or the tangent if you draw will be parallel to the x-axis. Clear? The tangent have to be parallel to the x-axis. So what are those points? Can I see this point? Yes, this is a point where f dash c would be 0. You may also say, sir, there is one more point, this. Yes, there is one more point, this. And that is why it has mentioned there that there will be at least one point. There should be at least one point. Getting my point? Right. See the diagram could be something like this also, na? This is between A and B. So there have to be one point. If f of A is equal to f of B, then it is quite evident that the curve will take a turn. The curve have to take a turn. It is cannot be monotonically increasing or a monotonically decreasing curve. Getting my point? Right? There can be a curve of this kind. Yes, fine. This is let's say A, this is let's say B. There have to be one point at least, right? Where your f dash c will be 0. The curve can have multiple c's. I'm not restricting. The curve can have multiple c's between A and B. Yes, but there will be at least one c which this will be happening. Clear? It is very quite evident. I've shown it with different graphs and different things, right? So this was basically Rolle's theorem, right? Similarly, we have something called as Lagrange's mean value theorem. So let us look at the first we talk about Rolle theorem. Second, we will talk about Lagrange's mean value theorem. Now what does Lagrange's mean value theorem says? Let us understand the statement. If a function fx is such that, I'm talking about the statement. First, fx is continuous in the closed interval AB. Second, f dash x, which is nothing but the derivative. F dash x, which is nothing but the derivative of x. This f dash x is continuous, or you can say f dash x exists in the open interval a comma b, right? Now here is no third condition. What was the third condition there in Rolle's theorem? F of a should equal to equal b. Here it is not necessary, right? And you can say, and f of a is not necessarily be equal to f of b, then there exists at least one c. There exists at least one c such that f dash of c is equal to f of b minus f of a upon b minus a. F of b minus f of a upon b minus, right? This is what is LMVT. What is LMVT? Lagrange's mean value theorem. Okay. So let's take an example on mean value theorem and understand how questions can be asked on this particular fundament. Let's say question is given using mean value theorem determine the value of c between 0 and 1/2 for the function if x is equals to x into x minus 1 into x minus 2, right? Options given to you are 1.764, B 0.568, C 0.3817, D 0.236. Now let us understand how will we solve this particular problem. First let us check. See, it is not mentioned which mean value theorem you have to apply. You can apply LMVT, that is Lagrange's mean value theorem, as well as you can also apply Rolle's theorem. So which you should use? Can you identify like this? No, you cannot. You have to check it with the condition. See, the two conditions that fx is continuous, we can see there is a continuous function, right? F dash is differentiable. Yes, we can see it is f dash x also exists. So we also have those conditions. Now we have to check whether f of a is equal to f of b or not, right? So let us check it out. What is a? A is 0. B is half. Right. Let me first define the function fx. Fx, if I say, is nothing but x cube minus 3x square, right, plus 2x. That is basically function. From where it comes, it is basically you will multiply x into x minus 1 into x minus 2 is nothing but this x cube minus 3x square minus 2x, right? So what will be f of b? F of b would be 1/2 cube minus 3 into 1/2 square plus 2 into 1/2, right? So if you solve this will come out to be 3/8. And what will be f of a? F of a is f of 0, so it will be 0 only, right? Now as you also need f dash of x. F dash of x will become what? X cube, sorry, differentiation of x cube will become 3x square minus 6x plus 2. So f dash of c will become how much? Just the variable is changing, so 3c square minus 6c plus 2. Now you know, according to you can see that f of a is not equal to f of b. So we can say that Lagrange's mean value theorem is applicable, isn't it? Right? So Lagrange's mean value theorem is applicable. So what we have to do is let us apply. If it is applicable, let us apply. F dash of C is nothing but f of b minus f of a upon b minus a. Right? So f dash of C, what is f dash of 3? 3c square minus 6c plus 2. What was f of b? It was 3 by 8, isn't it? Yes. Minus 0 upon 1 by 2 minus 0. Now this will form a quadratic. What will the quadratic look like? It will look like, you cross multiply and solve it, you'll get 12c square minus 24c plus 5 is equal to 0. Now can you split the middle term and solve? Quadratic, yes guys, you know how to solve quadratic, right? Splitting the middle term. Can it be splitted? No, it could not. So what will you use? We'll use determinant method to find the roots. Alpha beta c will be nothing but minus b, that is 24, plus minus under root of b square, 24 square minus 4ac upon 2a. Right? So if you further take a solving of it, you'll get 1 plus this will become 0.764. So this will come out to be 1.764 or 0.236. So these are the values of C you have got. Right? Now if I look at the option, we have both 1.764 and 0.236. Now whom to choose? There are two values of C we have got and we have done very correct. But there are two values. You wanted one value only, na? How will you get one value? Yes, very important. You have to get the C value between 0 and 1 by 2. So this will get ruled out. Yes, this will get ruled out. So value of C between 0 and 1 by 2 is 0.236. That's your answer. Option D. Option D will become your answer. Clear? So this is very important for us to understand how to solve these kind of questions. First is to identify whether it is a Lagrange's mean value theorem or it is a basically, yes, Rolle's theorem. Clear? Now there could be one more theorem which we can discuss here, that is called as the Taylor's theorem. Let us discuss that also. Okay, before going to Taylor's, let us also talk about something called as Cauchy's mean value theorem. Sometimes you will also come across Cauchy's mean value theorem. Cauchy mean value theorem is basically meant for two functions. Let's say it is mentioned to you if fx and gx are two functions such that fx and gx are continuous in the closed interval a comma b, f dash x and g dash x exists in the open interval a comma b, and there is a third condition which says g dash x is not equal to 0. Then f dash c upon g dash c is equals to f of b minus f of a upon g of b minus g of a. You can say then there exist at least one c such that this condition will get satisfied. Now it is very easy to understand what is happening here. We have talked about Cauchy's. Basically, this is a corollary of the above two theorems which we discussed. See, what is trying to say? Let's say this is a function. Let us say this is fx, and let's say there is another graph. This is between a and b. Okay. There is another graph. Let's say we name it gx. Right. This is again between a and b. Right. Now, if I say f of b and g of b will be the same, isn't it? Right. If you would have observed only fx, only the black part, you would have seen f dash c. There exists one c, f of b minus f of a upon b minus a, isn't it? Right. Between a and b. Right. And similarly, you would have said that g of b minus g of a will be the same thing. Correct. So in that particular case, what would have been told to you? B minus a from the denominator would have been cancelled. Right? If I say, for example, f dash c would have become f of b minus f of a upon b minus a, and similarly f dash of, sorry, for when you talk about g, that is a gx function, so you would have said g dash of c, not g dash of x, but g dash of c would have been g of b minus g of a upon b minus a, right? So if I divide 1 and 2, if I divide 1 by 2, you'll get this, isn't it? Very easy to prove also from Lagrange's mean value theorem only, right? So this is the third mean value theorem, that is called as Cauchy's mean value theorem, right? It's not very important from exam point of view, but still we have to understand, because you never know, a question may be thrown on this particular fundamental also. Now let us talk about Taylor's theorem. This is not the tailor who stitches your clothes, the name of a scientist basically. Taylor's theorem. So what else Taylor said was that, I'll talk about the statement first. Taylor said that if a function fx is such that case 1, fx and its first n minus 1th derivatives are continuous in the closed interval a comma a plus h. Now h is again a very small, infinitely small point. Wherever we are denoting h in calculus, always understand that that is the same h is a small, infinitely small point or a size which is tending towards 0, right? And second part he is saying is that f nx exists for every value of x in close interval a comma a plus h, then there exist at least one theta, you can say, where theta is between 0 and 1, such that f of a plus h is equals to f of a plus h times of f dash a plus h square by 2 factorial times of f double dash of a, and so on. We'll go on till h raised to n upon n factorial and upon f raised to n upon a plus theta h. So this is basically the crude form of Taylor expansion. You can also have a modified form. What is the modified form of Taylor expansion? If I say x is nothing but a plus h, right? So what will be a? A will become x minus h, or h will become what? X minus a. So if you want to find the modified form, you can say the modified form of Taylor expansion. The modified form of Taylor's expansion is f of x is equals to f of a plus h is x minus a times f dash of a plus x minus a square by 2 factorial times f double dash of a, and so on. This is the modified versions of Taylor expansion, right? Now what happened with this thing is Taylor gives this expansion for any function, right? He said that about a point a you can find out the expansion of any function in this particular fashion, but there was a scientist called as Maclaurin. What Maclaurin observed was, Maclaurin said ki no boss, this is not true. What Taylor have assumed is he has taken that all the values which he is taking is along a point a on the plane, because he is doing it along the point a. So for some functions it is correct, his observation is correct, right? But it is not a universal fact. He said it is not true for all the functions. So what Maclaurin said, and he named it as his own formula, and he called it Maclaurin series. Maclaurin series, or the Maclaurin formula, famously called as. What he said was, if you do the Taylor expansion across a point 0, that means across origin, then you will get the values or the expansion for each and every function in this universe, right? So what he said was, let us say he do it, what he is trying to do it, he is saying that in Taylor series or the Taylor's expansion or Taylor's expansion, take a is equals to 0. He is taking it across point 0. Then f of x will become f of 0 plus x f dash of 0 plus x square by 2 factorial f double dash of 0 plus x cube by 3 factorial f triple dash of 0, and so on. So this is basically known as Maclaurin's series or Maclaurin's theorem. Clear? So this is how it works in the Maclaurin case, right? This is how fundamentals can be tested. Now similarly you can also check it out, for example, if I say you want the expansion of fx is equals to cos x about point x equal to 0, you say it's expand fx equal to cos x about point x equal to 0. Now we can use Maclaurin theorem here. So fx according to Maclaurin is nothing but f of 0 plus x times of f dash of 0 plus x square by 2 factorial times of f double dash of 0 and so on. So let us first find out the values of these. What is f of 0? F of 0 would be cos of 0, which is 1. What is f dash of 0? Which will be nothing but sine 0, and that will be 0. What is f double dash of 0? It will be nothing but sine derivative. What is the derivative of cos? It will be minus sine, sorry, not minus sine. It will be minus cos 0, which will be minus 1. F triple dash 0 will be minus sine 0, which is 0. F fourth derivative of 0 will become cos 0, positive, that will be 1, and so, right? So we substitute this thing. So fx will become what? f0, that is 1, plus x times f dash 0, that is 0, plus x square by 2 factorial time f double dash x, that is minus 1, plus x cube by 3 factorial time f triple dash, that is 0, plus x power 4 by 4 factorial into f fourth derivative, and so on. So if you see, this will shortlist to 1, plus this term will become 0. So this is not plus, in fact you will be getting this to be minus x square by 2 factorial. This term again will become 0. So this is plus, so this is fourth derivative is positive, so you will say x raised to 4 by 4 factorial minus, it should be x raised to 6 by 6 factorial, and so on. And we know also that the standard expansion of cos x is this only. We have studied in our earlier standards also. So that is the answer. Clear how to basically solve this particular type of question, right? Let's take an example on this so we'll understand it much better. Let's say, let us take a GATE question which came in GATE 2008. In the Taylor series expansion of e raised to x about x equal to 2, the coefficient of x minus 2 raised to 4 is 1 by 4 factorial, 2 raised to 4 by 4 factorial, e square by 4 factorial, or e raised to 4 by 4 factorial. So Taylor series expansion of e raised to x will look like f of 2 plus x minus 2 into f dash of 2 plus x minus 2 the whole square by 2 factorial into f double dash of 2 plus, so there will be a term which will be x minus 4 to the power 4, sorry, x minus 2 raised to 4 by 4 factorial into fourth derivative of 2, isn't it? So actually you are looking forward for the coefficient of this term. That means you are basically looking forward for this term, whatever this is going to go, isn't it? Right. So if you solve this, fx is e raised to x, so f of 2 will be e raised to 2, and fourth derivative of this also is going to be e raised to 2 only, isn't it? Because e to the power x derivative e to the power x. So therefore the coefficient of x minus 2 raised to 4 is equal to e raised to 2 divided by 4 factorial. This is going to be e raised to 2 and this is going to be 4 factorial. So that's your answer. That's option number C. Option C will become your answer. Clear? So this is how you can solve questions based on this particular thing. Now you can start solving a question from your gate papers in your booklets. Easy to solve questions now, right? Thank you.